important types of angles. Central angles and inscribed angles. Okay. These are really important angles to know for circles. By knowing these angles, they're going to help us solve problems down the road. Okay. The first type of angle we're going to talk about is a central angle, and it is exactly how it sounds. A central angle is an angle that has a vertex at the center of the circle and extends to the edge. Okay. So we take a look at this diagram. Here's this angle right here, angle ACB. That is our central angle. Because the angle, the vertex C is the center. Okay. Its measurement is equal to the measurement of its intersected arc. The intersected arc is just the arc that's inside the angle. So if you go to the circle, our angle is highlighted in green. The intersected arc, you start at one opening of kind of like the mouth of the angle, and you go to the other opening of the angle. That's what we call our intersected arc. Okay? And the central angle and the arc are always the same. So AB is our intersected arc. So if the angle is 73, the arc's going to be 73 and vice versa. The arc's 73, the angle's 73. They are always going to be the same when it's a central angle. Questions over that? Another type of angle that's important is called an inscribed angle. And an inscribed angle is an angle that has a vertex on the edge. And the angles that are extending through towards the opposite edge of the circle. Okay. So we look in this diagram right here. This angle ACB is an inscribed angle because the vertex is on the edge of the circle. Makes it inscribed. Its intercepted arc is what? What arc is in between kind of the opening of that angle? AB. From A to B is its intercepted arc. I also like to think of it like green. The angle is like an ice cream cone. The angle is the cone, and the intercepted arc is like the ice cream or like a snow cone that goes on top. Visually when you're looking at it or drawing it. One important thing to know about inscribed angles is the angle is half the arc. So central angles, everything's the same. The arc and the angle, they're the same. Inscribed angles, the angle's half of the arc. So in this picture, the arc is 146. We would divide that by 2 to get the angle. Okay? Vice versa, if you're given the angle, we would multiply 73 by 2 to get the arc. Okay. Questions on that? Yes. Okay. Just follow along. I know you haven't been here. Do you have a pencil?
Yeah, I've got it.
Okay. Just, if you haven't been here, it's okay. Just follow along. Do your best. If we take a look at example 1, okay, first we're going to determine if the indicated angle is a central angle or an inscribed angle. Then we're going to find the value of x. Okay, so we're given this angle ABC. Identify, is that a central angle or inscribed angle? Central. On the center, it's a central angle. We want to find x. Is x an arc or an angle? Is x representing an arc or an angle? Representing an angle. And we know it's central, so we know about the angle and the arc. They're what? The same. So if the arc is 35, and again the intercepted arc is what's in the mouth of the angle. Right? If the arc is 35, that means the angle is going to be 35. So x is equal to 35 degrees. If we take a look at B, we need to identify the B got cut off. Angle A, B, C. Is that inscribed or central? What is it? Inscribed. Why is it inscribed? Yeah, so the vertex is on the edge. So it's inscribed. Okay? So, is x representing the arc or the angle? The angle. So, I'm going to go to the intercepted arc. What do we know about the relationship between the inscribed angle and the arc? What do we have to do with 44? Not times by 2, divide by 2. We're going from arc to angle when it's inscribed. You divide it by 2. So 44 divided by 2 is 22. If we take a look at C, we have L, K, J. Is that central or inscribed? Inscribed. Why is it inscribed? On the circles, on the edge. So it's inscribed. Okay? We're going to go to X. Is X representing an arc or an angle? An arc. So here's the arc that's represented. It's the intercepted arc. So what do we know about the relationship between the arc and the angle when it's inscribed? What do we have to do with 96? Multiply it by 2. So 96 times 2, what does that give us? What is it? 192? And this last one here we have GHI. So from G to H to I, what kind of angle is that? Is it central or inscribed? Central. Vertex is on the center. It's central. What do we know about the relationship? Is X representing an arc or an angle? Representing an arc. I'm going to highlight that arc. What do we know about the relationship between the angle and the arc of central? Or what? The same. So the angle is 139, the arc's 3139. Everything's the same with central. Questions over that? I think the hard part about this is remembering the inscribed angle, and if you're dividing by 2 or multiplying by 2. So if you look here, X was the angle. So if you look how wide it is, this arc is a lot more wider than the angle. So you would divide, because you're going from big arc to little angle. Here, the arc is very, very big, but the opening of the angle is smaller. So we're going from small to big, you would divide. So that's how I like to try to remember it. Okay. Central, everything's the same. That's an easy one to remember. Inscribed is a hard one. Questions over that? Okay. If we take a look at example 3, it's kind of like a puzzle. We'll go over that. We'll do 2 more and you get some time to practice. So with these, sometimes you're just given a diagram and you're told to find a bunch of different arcs and angles. So you have to use what you know about circles and central angles and inscribed angles to help you find those missing pieces. Okay. So we take a look at A. We want to find arc BD. We want to find that arc right there. Well, I know part of the arc is 58. Okay, so from D to C it's 58. I just need to figure out what that other little piece is, and then I can figure out the entire arc. Okay, so whenever something is missing, whether it's an arc or an angle, go to its corresponding piece. So if it's an arc is missing, go to the angle. What type of angle is that? Is that central or inscribed? Central. What do we know about a central angle and its arc? They're the same. So this angle is 32. What's the measure of this arc? 32. Well, now if we know what this piece and that piece are, what can we do with 32 and 58? Add them together. We just do 32 plus 58, and that will give us the entire arc. And what do we get when we do 32 plus 58? 90. So this entire arc, from here to here, is 90 degrees. Labeling your diagram is very helpful too. Okay. The next one we want to find arc ABC. So I'm going to highlight it. Highlighting is really helpful too, or drawing it, darkening with your pencil. So going from A to B to C. Well, what type of arc is that? Semicircle. What do we know about the measurable semicircles? They're 180. That one's easy. You don't have to do any work. I'm given a semicircle. I know that's 180 degrees. C wants us to find arc AB. So from here to here. Well, how do you think we can find arc AB? Trent? Perfect. We can do 180 minus 32. Because we just said that this was a semicircle. And we know part of that semicircle was 32. Well, if we just take away 32, then we know the rest of that arc. So if we just do 180 minus 32, that will give us AB. And what do we get when we do 180 minus 32? 148. That's 148. I'm going to write that a little bit better. D is asking us for our DAB. So I want to find from, I'll do orange, from D to A to B. So we almost have the entire circle. But what do we know about the measurement of the entire circle? Equals 360. Well, what do we know about the measure of this blue arc right here? It's 90. Well, we know the entire circle is 360, but we only know a little piece is 90. What can we do? I'll just do 360 minus 90, and that gives us what? 270. Okay.
And my stuff's up in my old room. She's going to check it and tell you that.
Okay. That's it. You're good. Okay. Sounds good. If we take a look at E, it says angle DOA. We want to figure out what angle DOA is. I'm going to highlight. From D to O to A. Well, whenever you're trying to find a missing angle, go to its arc. Right? Well, here's this intersected arc. It's this green arc right there. Do we know what that arc is? No. We can find it. How can we find that arc? Trent? Yeah, we have a semicircle here. And part of that semicircle is 58. So if we just do 180 minus 58, that will tell us what the rest of that semicircle is. So if we do 180 minus 58, what do we get? 122. So I know this arc is 122 degrees. What kind of angle is this? It's 122 because what type is it? You're right. Central. And we know central angles and arcs are the same. Oops, wrong place. Write that answer. So the arc is 122. The angle is going to be 122. Okay. And lastly, we want to find angle BOD. BOD. Well, if the angle's missing, go to the arc. So here's the arc. What do we know about the measure of that arc? It's what? 90. So the angle's also going to be what? 90. Because it's a central angle, and the arc and the angle are the same. So if the arc is 90, the angle will be 90 as well. Questions over that? I think circles are fun. It's like a little puzzle. And there's usually with circles, tons of different ways to get the right answer. And I'll show you this one. There might be multiple ways to get the same exact answer. Sometimes some ways take a lot less work than others, but you're still getting the right answer if you take a lot longer. Okay. Questions over that? Okay. If we take a look at example 4, it's saying if arc BC is 34, I'm going to mark BC and label it 34, Find the measures of the missing angles. So angle 1, 2, and 3. And we don't have to go in that order. Is there one angle we can find like right off the bat without doing really any work? Okay. Yeah, what's the measure of angle 3? 34. Very good. Because 3, if we highlight it, is a central angle. And BC is its intersected arc, and we know central angles and arcs are the same. So the arc is 34, the angle is 34. Is there another angle we can find kind of quickly? Which one? Well, 1 or 2. Because we only need to find one. The only angles that are marked. We don't need to worry about all the angles. What about angle 1? Here's angle 1. What kind of angle is angle 1? It's on the edge, so it's what? Inscribed, because it's on the edge. We go to its arc. Its arc is 34. What do we have to do with the arc to get the angle? Divide by 2, because we're going from big arc to little angle. So to get angle 1, we just use the arc divided by 2. What is the arc divided by 2? 17. Right? Here's where there's multiple ways to get angle 2. Because angle 2 is not central, and angle 2 is not inscribed, because this side of angle 2 stops. It doesn't keep going. So it's not any kind of special angle, it's just some random angle in a triangle. In order for it to be inscribed, it has to be like angle 1, and both ends have to touch the edge. Angle 2, it just touches the center, so it's not any kind of special angle. But I notice here, I have a triangle. Okay? And I know angle 1 is 17 degrees. But I also know that two sides of the triangle are both the radii of the circle. MA is a radius and MB is a radius. So what do we know about those two segments measured? So they're both the radius of the same circle. Very good, they're the same. So if these two sides are the same in that triangle, it makes us what type of triangle? What is it? It's an isosceles triangle. What do we know about the angles? If these two sides are the same, what do we know about the angles across from them? They're what? The same. So if 1 is 17, what's 2? 17. That's one way of getting that answer. Okay? You also could have thought about it this way. Some of you maybe worked ahead and did. We said at the beginning that angle 3 was 34 degrees. And I know angle 3 and the angle right next to it are a linear pair because they're on a straight line. They're right next to each other. So you could have done 180 minus 34. What is 180 minus 34? One 46? 146? Okay. So I know this angle is 146. And then what do we know about all the angles of a triangle? They all add to what? All the angles of a triangle add to 180. So you could have done 180 minus 17 minus 146, and it still would have given you 17. You still would have gotten the right answer. One way just might be more work than the other. So sometimes you just look at diagrams, it's just how you visualize it, how your brain works. You all see things differently. It's what I like about geometry because there's more than one way usually to get the right answer. Questions over that? We're going to do more work with central and inscribed angles tomorrow. Okay? But for now,